Hypothesis test about population means. So hypothesis tests about population means involve testing the hypothesis that compares the population mean of interest with a specified value. So the assumptions we make are that for all cases x1 through xn in sample size n, that there's a normal population with mean mu and variance sigma squared, that the mean of that sample is distributed normally with the mean of the population and the variance of the population. Now if n is large, x is going to be calculated similarly, even if the sample is from a non-normal population. Therefore, for large samples, the standard normal variable corresponds to x bar, which is the mean of the sample, is z. So what this is really stating is as sample size increases, the sample group is increasingly likely to reflect the true population. And that makes sense, right? Because if we had a sample size of 30, to extrapolate that out to 7 billion people may be extremely difficult. But if we had a sample size of 6.5 billion, to extrapolate that out to the last 500,000 people, we're likely to be much more accurate. So let's consider a random large sample size n with a sample mean. We want to test the hypothesis that the sample mean x has been drawn from a population with a mean mu and a specified value such that the mean is equal to mu subscript 0, which means the alternative hypothesis could be one of three. It could be that they're not equal, that it's greater than, or that it's less than. And under this null hypothesis, the saying the z-score follows the standard normal distribution approximately. When our population variance is unknown, we're basically going to use the z-test. So, same case, considering the following hypothesis that the mu equals mu subscript 0, the alternative is that they're not equal. So if it falls within the confidence interval, we're going to fail to reject the null. Otherwise, we get to reject the null hypothesis. And here, where the population variance is unknown, we're going to use the t-tests instead of the z.